The core components of a rack and pinion steering mechanism are the pinion gear, a rotating gear connected to the steering wheel, and the rack, a linear gear that translates rotational motion into linear motion. Pinion gear. This is a circular gear that meshes with the rack. Rotating the steering wheel causes the pinion gear to spin, which in turn moves the rack. Rack. This is a bar with teeth that mesh with the pinion gear. As the pinion gear rotates, the rack moves linearly, which is then translated to the wheels via tie rods. Steering wheel. This is the input device, allowing the driver to control the rotation of the pinion gear. Steering column. This connects the steering wheel to the pinion gear, transmitting the rotational motion. Tie rods. These are rods that connect the rack to the steering knuckles, which are connected to the wheels. The movement of the rack causes the tie rods to move, turning the wheels. With rack and pinion steering, the rotation of the pinion causes linear motion of the rack, which turns the vehicle's wheels left or right. Rack and pinion systems are a common component in railways. A rack and pinion steering system consists of a pinion, a circular gear, with a rack, a linear gear. A rack and pinion is a type of linear actuator that comprises a circular gear, the pinion, engaging a linear gear, the rack. Together, they convert between rotational motion and linear motion. Rotating the pinion causes the rack to be driven in a line. Conversely, moving the rack linearly will cause the pinion to rotate. The steering wheel turns a pinion gear, which moves a rack back and forth to steer the wheels. This mechanism converts the circular motion of the steering wheel to linear motion, which is applied to the wheels of the car via tie rods and a steering knuckle. Power steering helps the driver of a vehicle to steer by directing some of its engine power to assist in swiveling the steered road wheels about their steering axis. As vehicles have become heavier and switched to front-wheel drive, particularly using negative offset geometry, along with increases in tire width and diameter, the effort needed to turn the wheels about their steering axis has increased, often to the point where major physical exertion would be needed were it not for power assistance. Rack and pinion systems offer advantages like precise and direct control, compact design, high efficiency, and ease of maintenance, making them suitable for various applications, including steering mechanisms in vehicles and linear motion in machinery.